Hi there, welcome to a quick video tutorial for exponential functions here. What we're going to do in this video is compare linear, quadratic, and exponential functions, and we're going to do that using a tool called finite differences. The first thing I want to mention is that you should be able to identify a linear, a quadratic, and an exponential function simply by looking at the equation. So I'm hoping that you know that this is a line, this guy here is a quadratic, and this guy here is an exponential function. Okay, so lines are characterized by the degree of 1 on the variable. Quadratics or parabolas are characterized by a degree of 2, and exponential functions have a constant base. So in this case, I've got a 2, and that's being raised to some variable power. So that's the first thing you sort of need to know about comparing these three types of functions. All right, so the first example I want to look at here is asking me to analyze this table of values and classify this relation as either linear, quadratic, or exponential. All right, so the first thing I want to do is just take a look, and I can see that the x values are increasing by the same amount every time. I'm starting at -2, and I'm adding 1 each time. That's the first thing you got to make sure that your x values are constant. If they aren't, you can't really do this analysis. But what I'm going to do is I'm going to analyze the first differences, which essentially involves me taking this number here and subtracting the number above it. So I've got -2 minus -4. If you do that math very quickly, you'll see that the first difference there would be 2. First difference because it's the first difference that I can possibly take. I can take second differences, which would be the first differences of the first differences. But for the time being, I'm just simply subtracting the number above from the number below in my y column. So I've got 0 minus -2, also 2, 2 minus 0, also 2, excuse my 2 here, and 4 minus 2 is also 2. Okay, so you can see, sorry about that, you can see that I've got constant first differences here. If I were to take the second differences, I do 2 minus 2, and sure enough, I would get 0, and that would be the case for all of the subsequent sets of second differences. If I just quickly fill in this chart. Okay, so you can see here that I've got constant first differences. Constant meaning they are all the same number. Sorry about that. They're all the same number, resulting in a linear function. Okay, so if you have constant first differences, we can classify this relation as linear. All right, so if I were to just quickly do a sketch of this graph, I don't have an axis set up here, but if I start at -2, my y value is going to be -4, which, you know, I'm just kind of doing a rough sketch here, but you can imagine that point would be right here. -1 and -2 would be approximately here. 0 would be here, and you can kind of just imagine where that line's going. Right? You can see that it's definitely a linear function. Okay, so there's two ways you can classify a relation, which I just showed you. First one, just analyzing the first differences and the second differences. And also, you could graph the relation to see that it's linear. Okay, so in this case, we didn't need second differences. It is there for us. It's a good tool to have, just checking second differences. And you're going to see that when we look at the second example here. So same sort of question. We're analyzing this table of values. We're checking that our x values are all increasing by 1. We're going to do what our first differences first. So we're going to do 1 minus 4, and you'll see that you get -3. Okay. If you subtract 0 minus 1, you've got -1. So right away you can see my first differences 100% are not constant. So we don't have the same situation as we had in the previous example. Okay, so this is definitely not going to be a linear function, because remember, linear functions have constant first differences. Okay, we don't have constant first differences, so what we're going to do is look at our second differences. We're going to take -1, and we're going to subtract -3. That should give me 2. Okay, and again, we're going to subtract 1 minus -1, should give me 2. I'm having trouble with drawing 2's in this video. I apologize. I'm on a new computer here. All right, there we go. If I take 3 minus 1, I should also get 2. Now, you'll notice, like I said, I do not have constant first differences, but I do have constant second differences. Okay, so I'm going to just quickly do that. There we go. Yeah, I've got constant second differences. This suggests that my relation is quadratic. And again, I can graph this to check my answer. If I just very quickly plot over -2, up 1, 2, 3, 4, approximately here. -1, 1 would be here, 0, 0, 1, 1, and 2, 4. Right, so you can see that I've got a nice little parabola. I'm going to try to draw it. There we go. Looking something like a quadratic function. Okay, so 100% this is a quadratic. It is definitely not a linear, and it's not an exponential. Last example, you can guess what this one is going to look like. Again, so I've got a table of values where I'm increasing my x values by 1 each time. If I take my first differences, you can see 0.5, and I'm going to subtract 0.25. That should give me 0.25. Okay, so I'll fill that in. The next one here, 1 minus 0.5 would be 0.5. I've got 2 minus 1, which would be 1. I've got 4 minus 2, which would be 2. Definitely don't have first differences that are the same, so I can cross off linear. And you know what? You can probably tell that my second differences here are also not going to be the same. All right, I've got 0.25. Subtracting 0.5 from 0.25 will give me 0.25. 1 minus 0.5 will give me 0.5. So right away you can see second differences here, definitely not the same. So that kind of is a problem for us because we don't have a linear or a quadratic relation. But that's okay, because what we're going to look at here is a third column, which is the ratio of the y values. This is new to this video. We haven't done this yet because we haven't had to, right? We've either had constant first differences or we've had constant second differences. Because we don't have either of those in this case, it's helpful for us to analyze the ratio of y values. Now, what I mean by ratio of y values is similar to the first differences. We're going to take each y value and we're going to divide by the previous y value. And when we do that, you're going to see that I get this constant ratio. If I do 4 divided by 2, I get 2. All right, if I do 2 divided by 1, I get 2. If I do 1 divided by 0.5, maybe you can't do that one in your head, it's 2. Same thing with 0.5 divided by 0.25. So I do have a constant ratio of y values, which is one of the main characteristics of an exponential function. Okay, so I definitely have an exponential function here. If I were to graph this table of values in a similar way to what I've been doing in the previous examples, you'll see very quickly that this is in fact an exponential function. If I go back -2 and I go up approximately 0.25, somewhere in here, it gets a little tough with decimals. If I go back -1, up 0.5, 0, 1 would be here, 1, 2 would be up here, and if I go over 2, I'd be up to 4. Right? You can see I've got a nice, smooth, hopefully curve. Yep, definitely looking like an exponential function. Very rough sketch, but you can see here that this does not cross the y-axis. That's because this is considered the horizontal asymptote. You'll remember from maybe previous studies of exponential functions that a horizontal asymptote is a horizontal line that a function cannot cross, and that is one of the properties of exponential functions, is that they have horizontal asymptotes. If they're not translated up or down, you have a horizontal asymptote at y equals 0. So you can see here, I will not cross that axis. Despite this being a horrible sketch, you can see that. All right, so just a very quick summary of what we kind of looked at in this video. We talked about linear functions having constant first differences, quadratic functions having constant second differences, and we looked at exponential functions having a constant ratio of y values. All right, so that's the end of this video tutorial. I'm hoping you found this useful as you compare linear, quadratic, and exponential functions. Thanks for watching.